I'm really sorry the last video got cut midway because I suddenly received a call out of nowhere. It was from the company. It was a spam fraud call. So I was telling you about the shortcut, right? The shortcut to find the common difference. The shortcut to find the common difference is nothing but a2 minus a1, or the second term minus first term. You can choose any two terms, right? For suppose you choose a nth term, then you can just, let's forget about a nth term and whatever terms, right? You can choose any two terms out of the arithmetic progression if they are successive terms, like one after the other. They are two successive terms. So subtract the smaller term from the bigger term, or subtract or leave subtracting the smaller term from the bigger term. Subtract the term that comes before from the terms that comes exactly after that one, and then you would find the common difference. So for suppose let's we have to find the common difference in this sequence, right, in this arithmetic progression. So you have to subtract 12 from its successive terms, from the term that comes right after it, that is from 15. Or you can subtract 9 from the term that comes right after it, that is 12. Or you can subtract 6 from the term that comes right after it, that is 9. In this way you can find the common difference between in this arithmetic progression. Following similar way, these two terms are successive terms, right, like one after the other. If there was some there, you will also find some arithmetic progressions where there would be a little gap in between, and then you would given the last two terms, last three terms, or the last term directly. So you cannot subtract the last term, you cannot subtract this term from the last term that would be given, undermining the difference between them, undermining the gap between them that would be given for the terms that come in between. So just take two successive terms, like one after the other. These two are successive terms. So you can directly subtract minus 3 from you can subtract 0 from minus 3, and what would you get? You would get minus 3, right? Or you can subtract again, you can subtract here 6 from 3, then you would get minus 3, and that minus 3 is the common difference between them. See here, minus 3 is the d, right? So it's not necessary that you have to subtract the greater number from the smaller number. You can even subtract the smaller number from the greater number, given that you are subtracting the preceding term from the term right next to it, right after it, from its successive term. So similarly, this is also an AP and stuff. So in general form, in AP A1, A2 till the AN, we have D here. D is equal to A K plus 1 minus AK. This is nothing but the previous term, but that AK plus 1 is AK is the next term, right? AK is the previous term, and AK plus 1 is the term right next to it. So subtracting the previous term from the successive term, this is AK plus 1 minus AK. So let us suppose that there is a term AK, then the term right next to right after it would be AK plus 1, right? So we have to subtract AK from AK plus 1, that is the term from the term right after it. No need to go into the complexities, I've already explained it very thoroughly. So let's move ahead. For the AP, this is the AP, right? The first term A and the common difference D. This is a very easy sum. No need to take any stress over it. Okay, right? This is a very basic and very easy sum. No need to be afraid of it while watching that this is in a fraction. So how will we solve this? No need to fuss about it. It's very easy. So we already know what the first term A, that is what the first term or A is. It's obviously 3/2. Since the arithmetic progression is moving from this side to this side, we can conclude it from the dots. Since it's moving from this side to this side, so we can easily conclude that the first term here is 3/2. And what is the common difference? The common difference is nothing but 1/2 minus 3/2. See here, it is written 1/2 minus 3/2, which is what? Minus 1. Okay. So remember that we can find D using any two consecutive terms once we know that the numbers are in AP. Now, which of the following list of numbers form an AP? We will also have to find which of the numbers form an AP, or which of the terms are actually AP and which are not. And it is a very easy way to know this, to check this out. First, check whether the D is same in all the terms that are given, right? You just have to find out whether D is the same in the terms. If D is the same in between each two terms, then this is an arithmetic progression, right? And if D is different between any two terms of it, then this is not an AP. Let's take the first term for example. So D here would be 10 minus 4, that is 6, right? And then in the next term here it would be 16 minus 10, again it's 6. Then 22 minus 16, again 22 minus 16, yeah, again it's 6. So in each of the cases the common difference or the D is 6. Therefore this is an arithmetic progression. Now let's take the second one. So what should we add to 1 that it becomes minus 1? Right, what should we add to 1 that it becomes minus 1? Simply subtract 1 from minus 1. So minus 1 minus 1, it would be minus 2. So you would have to add minus 2 to 1 to make it minus 1. Then we will then minus 3 minus 1, minus 3 minus 1 would be minus 4 actually, but we will have to subtract it, right? So you would write it like this: minus 3 minus minus 1, right? So it would form up as minus 3 plus 1, that is minus 2. So we have to add minus 2 to minus 1 to make it minus 3. Then again we have to add minus 2 to minus 3 to make it minus 5. Right, so the common difference or the D between each of the two successive two terms is minus 2. So this is again an arithmetic progression. Now moving on to this one. Minus 2, what do we have to add to minus 2 to make it 2? You will have to add 4 to it, right? You will have to add 4 to it. Here you can see 2 minus 2 is equal to 2 plus 2 is equal to 4. So you will have to add 4 to it. Now what do we have to add to 2 to make it minus 2? We have to add minus 4 to it. So in the first case the common difference was what was the common difference? The common difference was 4. In the second between the other two terms the common difference is minus 4, right? In the first case it's 4, it's positive 4. In the second case it's negative 4. So this is not an arithmetic progression, right? Because the common difference is not the same. So this cannot be called as an arithmetic progression. As you can very well see from here, the given list of numbers does not form an AP. And similarly you can do it for the fourth term very easily by yourself. And we can clearly see that this is again not an AP, right? See, numbers does not form an AP. Now this is exercise 5.1 and I am sure that you can solve all the exercises by yourself very easily. So but still I would help you with the first exercise, for the first question or the whole of the exercise, because I'm not here to help you solve the questions. For that you can search the answers anywhere on YouTube, anywhere on the internet. I'm here to explain to you the concept so that you can grasp the concept very precisely and in depth, so you can solve all these questions by yourself and easily. The taxi fare after each kilometer when the fare is rupees 15. So we have to find in each of the following situations does the list of numbers involved make an arithmetic progression and why. So they are saying in each of the following situation is an arithmetic progression formed using the numbers that would be formed out of this situation, and if so then why is it formed. So the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer. So we have to note two things. First is rupees 15 for the first kilometer, and then after each kilometer rupees 8 for each additional kilometer. We have to note this thing that it is rupees 8 for each additional kilometer. So for the first kilometer, let's just write it here. For the first kilometer it is equal to rupees 15, right? For the first kilometer, for each additional kilometer or every other kilometer, you can write whatever you want to write here. You just need to understand what you have to find. For each other kilometer it's rupees 8, right? So what it is saying that if you travel the distance of 1 kilometer you will have to pay a fare of rupees 15. If you travel a distance of 2 kilometers you will have to pay a fare of rupees 15 plus 8. If you travel a distance of 3 kilometers you will have to pay rupees 15 plus 8 plus 8, and it will go on so on, right? So if you travel a distance of 4 kilometers you will have to pay rupees 15 plus 8 plus 8 plus 8. So what this is saying that this is a way, suppose this here is 1 kilometer, 2 kilometers, 3 kilometers, finally 4 kilometers, right? So for the first kilometer the fare is 15 rupees, and for each additional kilometer you will have to pay the initial fare, of course, of 15 kilometer, but for each extra kilometer that you take, you will have to pay rupees 8 for it, right? So rupees 8 for this kilometer, then rupees 8 for this kilometer, then rupees 8 for this kilometer, right? So does this form an arithmetic progression? Like I said, we do not have to add, like we do not take the first term to be subtracted or anything and added anything to it. So the first term can be anything, like literally anything. It starts from the second term. From the second term, we realize whether it's an arithmetic progression or not, and not even from the second term, basically from the third term we can have an idea whether it is an arithmetic progression or not, right? So this is the first term. This is the first term, that is 15. Then we add 8 to it. What does it become? 15 plus 8, 5, 6, 7, it becomes 23, right? Then we add plus 8 again into it for another additional kilometer. Then what does it become? It becomes equal to 31 rupees, right? So it will go on like this, but each time you can see that each time to the preceding term 8 is being added here. Here the first term is 15, then 8 is added to it and it becomes 23, that is the second term. Then 8 is again added to it and it becomes 31, that is the third term. Then 8 is again added to it and becomes 39, that is the fourth term. So the common difference, so the number goes like this: 15, then 23, then 31, then 39, and it will go on so like this, right? This is your arithmetic progression that forms out of this situation. And you can clearly see that the difference between both the successive terms is 8, right? The common difference in all of this arithmetic progression is the same. So this can be called an arithmetic progression, right? This satisfies the situation for an arithmetic progression. And the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. At a time means at a particular time. It can be 10 seconds, 20 seconds, 50 seconds, whatever time it takes. So whatever they are saying is that the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So each time 1/4 of the air is removed. We know that the complete cylinder would be full at 4/4, that is at 1. So 4/4 or 1 minus 1/4, right? And whatever would come, that will be your second term, and then again you would have to subtract 1/4 of it, right? So this is not an arithmetic progression. And why it is not an arithmetic progression, let me explain it to you in a very simple manner and very realistic manner. So let us take this to be a cylinder, right? This is a stupid cylinder. It is completely full to the brim. Let us take, for instance, that it has 20 liters of gas. It has 20 liters of gas. Now at every 10 seconds it removes, or at every interval of time, at every other interval it removes 1/4 of its gas, right? So in 10 seconds it would remove this much gas. So that means that it would remove 1/4 of 20 liter, right? So 20 is 1/4 is what? It's nothing but 5, right? So it removes 5 liter gas each time, or each 10 seconds it has removed 5 liters of gas. So 5 liters of gas is removed from it. Now the next time also it will remove 1/4 of the gas. They have not said that it will remove 1/4 of the gas of the when the cylinder is completely filled. They have only said that it removes 1/4 of the air remaining in the cylinder at that time, or at a time. So whatever amount of air remains in that cylinder at that time, it will again remove 1/4 of that air present. So now it is not 20 liters of air present in it. Now only 15 liters of air is present in it. And again it would remove 1/4 of 15 this time, not 20 but 15, which would be what? 4 3s are 12, then 30, 4 7s are 20. It would be 3.7 liter, right? So in the first case it has removed 5 liters of gas, but in the second case it has removed 3.7 liters of gas, right? So we can clearly see that the common difference between each successive term is not the same, hence it is not an AP, right? Because the common difference each time, if the same amount of gas is removed from the cylinder, then it would make an arithmetic progression, right? Because the same same pattern keeps on going, but the pattern keeps on changing because the amount of gas left each time is less and less, but the equation or the ratio of gas removed is in accordance to the gas left inside the cylinder. Okay, so this is how you can identify whether it is an arithmetic progression or not. In the second question, write first four terms of the AP. You can very easily write the first four terms of an AP. Since you have given the common difference in the first term, A is the first term, you just have to keep on adding the common difference to each term that you get. First term is 10, add the common difference, becomes 20. Then you get another second term, that is 20. Then again add common difference to it, that is D, add 10, it becomes 30, right? You get the third term. Then again at 10 it becomes 40, you get the fourth term. Keep on going wherever you want to end it, it's up to you. You can basically you just need to write the 3 or 4 term, that's enough, more than enough. So in this you can find the common difference very easily. 1 minus 3 minus 1 minus 1 minus 3 minus 1 right it would become actually plus, kind of. So you can solve all these questions very easily, right? This is our first exercise ending, and the nth term of the FNAP would be explained in the next video.